this turned on? Yes. All right, so here's what we've got going on here. We're going to write a function if these are the roots or these are the x-intercepts. Do you see where we are? I need you to get out the sheet that you picked, the other sheet. Turn it over. There you are. We're right here. I'm not ripping your paper up. We're on this sheet. I'm going to switch to the other page. Max, switch to the other page. Find this paper, please. Yep, right here. Okay. Know where we are now? Help your group members out. If you see somebody in your group who's not on the right page, could please help them. All right. So if these are the x-intercepts, we want to find its function. So what we're going to do, first of all, they don't always say x equals. They might just say 4 and negative 3.
4 and negative 3.
Right? So you want to make sure that you set them equal to x. If x equaled 4, what would be its factor?
5.
Okay. So I'm going to subtract 4. What about this factor? 3. So I would add 3 to both sides. And then we're going to multiply them together to get it in standard form. We're going to FOIL it. Remember how we said the roots and the factors were essentially the opposite of each other? That's what we're doing so far. So we have x times x, x times negative 4, 3 times x, 3 times negative 4. And then we want to combine like terms. So this would be our function. This is our parabola. How does the parabola open? Up or down?
Down.
Brendan, how does it open?
Down. Up. Oh, yeah, I answered that. Up.
Yeah, you did. Okay, it opens up. How do you know?
Because x is positive, right?
Which x? Watch your mouth, please.
X squared.
X squared. So you know the answer. X squared is positive. So it opens up. It's going to look like a U. What's the y-intercept? Morgan. Negative 12. What were the x-intercepts? Kyle, what were the x-intercepts? No. 4 and negative 3. See, in the problem, I'm giving you the root, asking for the function. Okay. How do you find the vertex?
Graph it.
Graph it. Okay, yes, we could graph it. How else do you find the vertex? Negative b over 2a. Where does a, b, and c come from?
Standard.
Okay, what would a be, for example? 1. So this would be our a, negative 1. That's a terrible color, isn't it? Can't get this to move. There we go. So 1 would be a, negative 1 would be b, and then this is our c. So to find vertex, we would have used negative b over 2a. All right, just trying to review a little bit. All right, let's try another. Sometimes the x-intercepts are fractional. They're fractions, so we're going to have to learn how to deal with those. So again, we want to make sure that it's x equals the number, and we're going to change those into factors. All right, now, I wrote a little bit different in the parentheses. It says do the denominator first. I do not want to subtract 1/2 right now, because when I go to multiply, I don't really want to multiply fractions, if that's all right with you. Okay? So we're going to take care of the denominator first. How do you undo dividing by 2? Multiply by 2. So I'm going to multiply both sides by 2. So I get 2x equals 1. And I'm going to move the 1 over the equal sign, so I'm going to subtract. So now it equals 0. I'm going to do the same thing for the 3/4. So how could I get rid of this 4? Okay. Pardon you. So we get 4x equals 3. Then what? 4x minus 3. See, so now when I go to multiply to get it in standard form, I don't have to worry about the fractions anymore.
So all you gotta do is get rid of the fraction and just multiply by the number.
By the denominator first, It will work, but you're going to get like a multiple of that. Like you're going to have fractions all in your coefficients.
So wait,
Yes.
you have to do that, right?
At some point you need to clear your fractions, yes.
Okay.
So we're going to multiply these together to get it in standard form. Combine like terms. So the ones in the diagonal usually go together. I'm going to put a little f of x out there. Here's our function. Okay.
Is that all you have to find, or do you have to like clarify what the x-interception is?
No, I just did that as a review. Yeah. All right.